All right, so we're going to do the last two problems on the team round for the 2015 State Math Counts Team Competition, and we got two really cool problems. Number 9, the first different prime numbers, 6 different prime numbers are placed in 6 different circles shown. The 3 circles on each side of the triangle have the same sum. So what is the least possible value of the side sum? All right. So we have this sort of magic triangle. We're going to have the same sum no matter which 3 sides we look at. And so we're only dealing with prime numbers, and that helps us narrow the field. And so I'm going to write some prime numbers. So we have 2, 3, 5, 7, 11, 13, 17, 19, 23. Okay, I'm running out of space. And so right away, before I just willy-nilly start putting numbers in here, I need to narrow the field of possible numbers. So I'm looking at this, and I realize that if I have an even number in this, things are not going to work out well, because I'll have an odd plus an even on one side, or maybe 2 sides if I put it in one of the middles, but then the other side will have all odds, and so it can't be equal. So I can eliminate 2. So then I'm looking at these numbers, and I notice there's a difference of 2, a difference of 2, a difference of 4, a difference of 2, a difference of 4, a difference of 2. And so really what I kind of want to have is I kind of want to have groups of numbers that have the same amount of difference. That way I can make things work out much better here. And so I'm looking for the least possible value. So I'm probably going to want to use this pairing of 2. These 2 are only 2 apart, and these 2 are only 2 apart. And so it's a really good bet that the 6 numbers I need to use are 3, 5, 11, 13, 17, and 19. So that's what I'm going to use when I go through my guessing and checking. So I'm going to go ahead and do some educated guessing and see if it works, right? So I know that I'm not going to be able to have both numbers in each pairing in one line. So I'm going to start putting things sort of away from each other. So let's start with the 3. So 5 I don't want with the 3, so I'm going to put a 5 here. Let's put 11 here. So let's put the 13 here across from it, and let's, So where am I now? So right now I have 14 here, I have 16 here, and going this way I have 16 also. Well, that's encouraging. I have 16 here. So then I have 14, which means this needs 2 more than this, right? So let's go 19, and that would make this 17. And so this gives me 33. There we go. That's it. 33, 33, and 33. And so the trick with this one is I was trying to keep these pairings away from each other, so I was going directly across the triangle. And that's it. So the answer is 33. Finally, 2 integers have the property that when their sum is added, so that's 2 numbers, to their arithmetic mean of their squares, so that would be x squared plus y squared divided by 2, we have a result of 64. What is the greatest possible value of the product of these 2 integers? So this is telling me that there are multiple answers, just like there were here. And there are only going to be probably 2 possibilities here, because we have a fixed number, a fixed solution, so there must be 2 ways of getting this, unlike this one where there's no one fixed solution. So let's write out some square numbers dealing with this. So we have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 120, 144. Sorry, I paused the video. I had to go take care of some kids that are way too loud in Yema's room. All right, so I went over the 64 here because I know I'm going to be dividing these square numbers by 2. And there are two ways to get to 64, right? I could have, this could be less than 64 and I add to 64, or it could be over 64 and these can move down to 64. Down to 64? That means that these two would have to be negative. And I want a product, and I'm multiplying two things together. And so if I had a negative times a negative, I'd end up with a positive product. That's the key. I'm going to have negative numbers here so that x and y are farther than, have a larger absolute value than the positives. That would be then adding up to 64. So, all right, so if I add together, let's start big. 100 and 121. Well, we know we're dividing by 2, so I can get rid of all of the odds. So we have to be dealing with even numbers here. So let's start with these two. All right, so 100 plus 144 is 244 divided by 2, and that's going to be 122. The square root of that is 10, the square root of that is 12, so that's minus 22, and that gets me to 100, but I need to get to 64. So I know that this combination is too big. So I know this is out. So let's try these two. So we get 164 when I add them together, divided by 2 is equal to 82, right? And so we're 82, and then square root of this is 10, square root of that is 8, so that's minus 18, and I get 64. So that means that x and y have to be negative 10 and negative 8. Because remember, I subtracted the 18 to get down there. And so the product of these two is going to be positive 80. And there I go.